In this video, I'm going to go over implicit differentiation. So what is implicit differentiation and why do we use it? Well, implicit differentiation is usually taught the section after the chain rule because it really just is an application of the chain rule. And what do we mean by implicit differentiation? Well, sometimes it's easier to take the derivative of an equation in its implicit form over its explicit form. So for example, here I have the standard equation of a circle, and I have y equals the square root of 25x squared. So that is explicitly solved for y. Now, it's not bad to do the derivative here. It looks like it would be a chain rule, but sometimes it's easier just to take the derivative in its implicit form. And what we mean by that is, let's say we're taking the derivative with respect to x. Well, we're going to treat the other variable, in this case here, the y variable, we're going to treat that kind of like the chain rule where that's the inner variable or the inner function. So let me show you some examples. We'll start out with some basic examples, then we'll move to some examples that you might see on an AP test. Okay, so in our first example here on the top left, I have the derivative with respect to x of x squared. So what happens with implicit differentiation, if the variables match up, so we're with respect to x here, and we have an x squared, we just do our normal derivative. So in this case here, by the power rule, this would be 2x. All right, in our next example, we are with respect to x, but now the variable inside the parentheses that we're taking the derivative of is a y variable. So what happens is this becomes similar to a chain. So what we're doing is we're taking the derivative of, let's say, the outer function y squared with respect to y. So it would be 2y. We don't know what y is, so what we need to do is we need to multiply this by the derivative of the inside. And in this case here, it would be dy dx. So that's how implicit works. So it really is the chain rule. All right, so let's look at a common example. In the next row here, we have the derivative of the area with respect to time. So dA dt, and we're doing the pi r squared. Okay, so I look here. My t variable does not match up with the r variable that I'm taking the derivative of. So what I'm going to do is I'm going to take the derivative with respect to r. So that would be 2 pi r. And then I have to multiply this by the derivative of r with respect to t. So I would need a dr dt multiplied to that. Okay. We look here, I have a volume. Let's say we have the volume of a cube here, side cube, and we want the derivative of that with respect to t. So again, my t does not match up with my s, so I have to take the derivative of the outer, which is the cubing function. So I would get 3s squared, and I need to complete the chain by taking the derivative of s with respect to t. So that's just the basics starting out with implicit differentiation. So let's go back to the example using the circle. Okay, so let's take the derivative in its explicit form first, so we can compare the difference. So in this case here, it looks like we have y equals 25 minus x squared to the half power. So this would be 1/2 times 25 minus x squared to the negative a half times the derivative of the inside, which would be negative 2x. So I would get, if I simplify this, negative x over the square root of 25 minus x squared. Okay, so that would be y prime. Okay, so what if I did this implicitly? All right, so to do it implicitly, what we're going to do is we're going to work left to right. So remember, our goal here is we're finding dy dx, which is y prime. So we're with respect to x. So anytime I don't have an x variable when I take the derivative, I have to do that implicit part, which is multiplying by the derivative of the inside. Okay, so I work left to right, so the derivative of x squared with respect to x, well, the variables match up, so it's just 2x. The derivative of y squared with respect to x, now y squared, y is a different variable than x, so I'm taking the derivative of the outside, which is 2y, but to finish the chain, I have to multiply this by a dy dx. That's acting as the derivative of the y variable, or the inside. And then the derivative of the constant 25 is 0. Okay, now what you want to do is you want to isolate the dy dx by solving for it. So we would get dy dx is equal to negative 2x, and then we would be divided by 2y. So we would get negative x over y. Now you can see that we're close to our answer we got when we did it explicitly, but what we need to do now is we need to go back and sub in y, and in this case here, dy dx would equal, we can see over here that this does equal y, so we get negative x over the square root of 25 minus x squared. Okay, now was it that much easier doing it implicitly? In this case here, no, they were both pretty simple derivatives, but you'll see in the next video as it gets more complicated where you're going to need to do it implicitly. Okay, let's try a product rule problem where we're going to have to use implicit differentiation with it. So if I wanted to take the derivative of x times y with respect to x, so the derivative of x would be 1 times y plus the derivative of y, which would be, in this case here, the derivative of y is 1, but it's implicit, so we need a dy dx, and then times x. So that would be y prime, or dy dx, when we're doing the product rule along with implicit differentiation. Okay, so let's look at the derivative of dv dt, and we want the derivative of pi r squared h. Okay, so in this case here we have two letters that don't match up to the t. Okay, so we're going to do the same thing, same technique. This is going to be a product rule again, and I can factor out the pi because it's a constant. So the derivative of r squared with respect to t would be the derivative of r squared with respect to itself, so 2r times, it would be implicit because the t and the r don't match up, times dr dt times the h plus the derivative of h with respect to t, which is the derivative of h with respect to itself is 1 times dh dt times r squared. So that would be dv dt using the product rule with implicit differentiation. All right, let's find the equation of the line tangent to the curve x squared y plus 3x equals y squared plus 1 at the point 1, negative 1. All right, so to create a tangent line, I need a point and I need a slope. So I'm going to need the derivative here to get the slope. So what I'm going to do this with implicit differentiation, I'm going to work left to right. All right, so I'm going to start with the x squared y term. That is a product rule. Now remember, we're doing this with respect to x. So the derivative of x squared with respect to x would be 2x times the y plus the derivative of y with respect to x, which would be 1 dy dx times the x squared. So that would be the first term's derivative using the product rule, plus the derivative of 3x with respect to x. Well, the x matches, so it's just normal derivative 3 is equal to the derivative of y squared with respect to x, so that would be implicit. So the derivative of y squared with respect to itself is 2y, but then we need a dy dx, and then the derivative of 1 is a constant, so that's 0. So now there's a couple ways to do this. You can plug in the point 1, negative 1, and solve for dyx that way. Or you can solve for dy dx, get the answer, and then plug in 1, negative 1. I'm going to do it that way just to show you the technique here. So what we want to do is we want to get all the dy dx's on the same side, all the terms without the dy dx on the other side. So that means I have to bring the 2y dy dx over to the left to start. So I'm going to get, let's rewrite this as x squared dy dx minus 2y dy dx is equal to, and then I need to bring this over and this over to the other side. So negative 2xy minus 3. I'm going to factor out a dy dx. So I would get dy dx times x squared minus 2y is equal to negative 2xy minus 3. I'm going to divide both sides by x squared minus 2y. So I would get dy dx is equal to negative 2xy minus 3 divided by x squared minus 2y. All right, so that's the formula for the slope. That's the derivative. So what I want to do now is I want to plug in 1, negative 1 to get my slope value. So dy dx would equal negative 2 times 1 times negative 1 minus 3 divided by 1 squared minus 2 times negative 1. So the top looks like it's going to come out to be 2 minus 3 is negative 1. And the denominator looks like it's going to be 1 plus 2. So that's 3. So that means my slope is negative 1/3. So that means the equation of my tangent line in point slope form would be y plus 1 is equal to negative 1/3 times x minus 1. All right, in the last example, let's find the second derivative with respect to x. All right, so the strategy here is we're going to get the first derivative, and then we're going to do the second derivative. And now what you'll see when we do the second derivative, if you get a dy dx in that second derivative, you're going to sub in that first derivative. So let me show you. So we go left to right. So we would get 2x plus 2y. Now remember the y doesn't match up with the x, so we're going to need a dy dx is equal to the derivative of the constant 100 is 0. So if I solve for dy dx here, I'm going to get negative 2x divided by 2y, which would be negative x over y as my first derivative. Okay? So we're going to take the derivative again to get our second derivative, and we can see here we have a quotient, so we're going to have to use the quotient rule. All right? So quotient rule, low d high. So low is y times d high is negative 1 minus high. High would be negative x times d low, the derivative of low, and the derivative of y is, in this case here, implicit. So it'd be 1 dy dx. All divided by low squared, so divided by y squared. So simplifying this, I would get negative y plus x. Now I'm going to sub in dy dx. So I can see here I have dy dx, which equals this. So I'm going to put in that negative x over y divided by y squared. So this would simplify to negative y minus x squared over y divided by y squared. So if we wanted to simplify this farther, we would get, looks like we would get negative y squared minus x squared over y divided by y squared, which would equal negative y squared minus x squared over y to the third. Okay, I hope you liked the videos. If you did, please like and subscribe. Have a great day.